So now we're going to run our experimental task. Naturally, the first thing that you need to do before you commence the task is to explain it properly to the participant. The participant will need to understand all the rules of the task, any limitations that there might be in place for the EEG recording. For example, whether or not they're allowed to speak. Of course, they need to be allowed to speak if there's a problem, and that should always be the case in any experiment, regardless of if it's EEG. But you are allowed to request to minimize speaking during an experiment, particularly for EEG. That might be a good idea. You also need to remind the participant to relax or to sit with a certain posture. We want to make sure that we minimize the amount of tension that might be in place in the back, particularly the shoulders. So you want to avoid hunched up positions that could end up causing muscle artifacts, particularly into the occipital electrodes. That's very important because, as I showed you earlier, if we're going to be interested in targeting alpha frequency, for example, well, alpha ends up being most strongly shown in the posterior and occipital positions. So the last thing we want is to create a lot of muscle tension that interferes with this signal. So making sure the participant is in good posture and relaxed is very important. Now, for today's tasks, we're going to try to do something fun for this video, but also in the spirit of doing something ecologically valid. So in human-computer interaction science, and often at what we do at the Tech3lab, we try to do tasks that are close to what people do in real life. So playing games is something that people do in real life, and using EEG to understand brain activity during a real-life task is something that is very important to the Tech3lab and something that we pride ourselves in being able to publish. So today we're going to run 2 games. These games differ according to their level of difficulty. We have a simple game that doesn't involve much mental effort. This game will involve a caterpillar that is controlled by the mouse, and it moves around the screen, and it will eat cakes and sweets and things, and it will grow larger. The goal is simply to not run into anything else and not die. It's very easy. It doesn't require any sort of multitasking. It's going to use visual processing. There will be some minimal motor processing to control the mouse. But again, this is a realistic kind of experiment. So we'll try to minimize that, but we will permit it. The second task that we'll run is much more difficult. It's a multitasking task. The participant will have to control various different objects simultaneously on the screen and keep them in a state of equilibrium. As you'll see later when we start the task, it starts out simple but gradually increases in complexity. The idea here is that we should be able to very clearly, when we go to analyze this data, see differences in alpha amplitude, because alpha amplitude will change according to the extent to which there is cognitive load being leveraged during the task. So we should expect that there will be more cognitive load in the difficult task. We should see more alpha desynchronization. That means a decrease in the amplitude of alpha compared to the simple task. You won't be able to see that very well live. Earlier you saw how eyes closed and open led to a slightly observable change in amplitude of the signal. But the subtle changes that are going to happen in difficulty between 2 tasks often are not strong enough for us to be able to see with our naked eye. It will require post-processing, which we will discuss in a separate video series. So let's get to the task. We're going to start with the caterpillar task. Anne, are you ready to try?
Yeah, I am.
Okay. You have the mouse?
Yeah.
Okay. Please go ahead and click play as guest. Okay. So, Anne, your job is to eat the food. So, now that Anne has started the game, I'm going to enter my marker. Maybe you couldn't see that, so I'll enter in my marker one more time. We'll wait for it to come around so you can clearly see it on the screen. The fact that it wasn't actually the start of the task is not so important. It's just to mark the beginning of an analytical time window where we will go and in post-processing look at the alpha amplitudes. So this is an example of a kind of study where we're going to look at what we call band powers or perform a band power analysis. And I mentioned alpha amplitude many times, so obviously this is going to be one of the primary targets. There are other sorts of processing targets that you can have with EEG, the most famous of which is an event-related potential, or an ERP. This sort of analytical target requires slightly different design, with lots of shorter trials that are repeated over and over. Both approaches are valid in EEG research and can be used in human-computer interaction studies. For the purposes of this video training, we're using a band power approach, and hence the very natural sort of task that you see here. Anne's caterpillar is getting quite large. You're good at this. Normally you don't talk to the participant during the study, unless it's absolutely essential. So typically, we need at least a few minutes of noise-free EEG activity for our analysis. It can vary from study to study. Some studies will have multiple trials, and that could be the case. For example, we could have a number of trials of a very simple task. We could repeat this task multiple times, for example, and then average those trials together at the end. For the sake of simplicity in this training, we're just going to do a single trial with a couple-minute window, and then we'll move on to the next task. So I'm going to wait until the signal comes around again. I'm going to mark my end marker. So there's my task 1 end marker. So that'll let me know that that's when I need to stop my analysis for the first task. And you can go ahead and stop, or you can find another worm to kill yourself. If you can't, I'm just going to end it for you.
Yeah.
Okay, good job. All right. So we'll close that and move on to our next task. So our next task, as I mentioned, this is a multitasking task. It's going to start out easy, but it will gradually increase in complexity. So because I know ahead of time that it will increase in complexity, I'm going to wait until we move into a multitasking state before I enter in my marker for the start of the task. In that way, I'm going to allow the participant to acclimatize to the task, but at the same time, I'm going to minimize the extra unneeded amount of EEG recording that I should be targeting in my analysis. So Anne, we're going to try this. Go ahead and press play now, and we'll read the instructions together.
Okay.
Please press play and play. So the task will start out very simply, as I said. The goal for Anne is to use the right and left arrow key to keep the ball on the platform. Okay?
Okay.
The platform will try to tilt. So you need to make it tilt the opposite way to keep the ball on there. Let's try. Press any key to start. So again, I will wait until a second task comes in here to actually put my marker. Okay, so now we've moved into the simultaneous multitasking state. So Once Anne starts this part, I'm going to add my marker. So Anne, now you have to use left and right for the ball. And on the right side, you will see some arrows. They will come from the left side and the right side. And you have a blue cursor. You see the blue cursor?
Yes.
Okay. You need to move the blue cursor up or down.
Yeah.
Don't let the arrow touch your blue cursor. Okay?
Okay.
So Anne will have to think about both these things at the same time, keeping track of them in her mind. This should increase cognitive load. When you're ready, Anne, press any key to start.
Okay.
So I've entered in my start for task 2, and Anne is going to try to keep both these things in equilibrium. So far, so good. Excellent. Now, as you can see, the state is increased in complexity even further. I'm going to add an end marker here. Here's an example where I can take advantage of multiple trials. I don't need to analyze the brain activity during this part of the task where she's not doing anything. So we'll make sure that I only analyze parts where she's actually using her brain for performing the task. So Anne, now we have 3 things to keep track of. You have the left and right arrow for the ball. You have up arrow and down arrow for the blue cursor. And you must use your left hand, okay?
Yes.
On the W and the A and the S and the D, okay? W is for up.
Okay.
S is for down. A is for left. D is for right.
Okay.
Okay? And you have a green square. That green square, you must move and you must touch the other square. So another square will appear and you must go and touch it.
Okay.
Yeah? And you have to hurry because it will disappear.
Okay.
But don't forget about the ball and the blue cursor.
Okay.
Okay, when you're ready, we can start.
Okay.
So I've added my marker for the next trial. And you can see that it's so difficult. Quickly the ball fell off. Good job, Anne. It's very hard. You want to try again?
Yeah.
Yeah? Okay. So I made sure I added my end marker. Go ahead and play like some practice ones.
Okay.
Yeah. Oftentimes in experimentation, it's okay to have a practice version of the task itself. And there are some cases where allowing the participant to see the task before they do it can bias their natural response during the task. Sometimes we develop separate but similar stimuli just for the practice portion. For the case of this training, it's all right. We'll allow Anne to continue this. And I'll be ready here. I'm going to add another trial. And it's very difficult. You can try it one more time. Being able to have multiple trials of a task is very helpful because you never know what sort of noise artifacts might be present in any given trial. The more trials you have, the more you can average out that random noise and be left with the actual neurophysiological signal that is representative of the cognitive state required for performing that task. So keeping two things in equilibrium is relatively easy. Once we get to 3, you can see that the difficulty is exponentially higher. Very good. Good job. It's okay. It's supposed to be impossible.
Okay.
So Anne has been a very good sport. And the last thing I would like to say to the viewers of this training is that in cases where you are unable to have multiple trials, we can still use that data and analyze it in a multi-trial fashion by dividing up the trial into sub-segments. I'll explain that later in the EEG processing video tutorial series that we have separately from this. So thanks for watching. We're going to close up the task and the recording now. I'm going to press stop up here. And now the EEG recording has been stopped. It should be saved. And we're going to move on into getting the participant out and have their hair washed and on with the rest of their day.